if your data is skewed, it is probably not enough to say it's skewed and the mean is this and the standard deviation is this. That's why if it's skewed, we'd probably prefer to say do this. And if it's skewed, you would want to make sure you mention the median, you mention the quartiles, you mention the range, and you mention the IQR. So if it's skewed, you have a little bit more work to do in that you'd want to probably include all 4 of these summary statistic things. Whereas with symmetric data, you can probably just say here's the mean and standard deviation. Okay? But these are just kind of preference things. Again, you can calculate all of these numbers for any set of data. Let's not get hung up on this point, but is that a question there? Or no? Okay. All right. I feel like sometimes you say just a tiny bit too much, and then you realize you've opened a can of worms, and you're like, oh, that's... Okay, let's talk about the mean. The mean is often the word that we think of when we hear the word average. So generally, when you hear the word average, it is generally referring to the mean. Occasionally, average refers to the median, but generally, refers to the mean. I think many of us are already familiar with the mean. I'm going to write the formula for the mean. The symbol that we use for the mean is x bar. Sometimes we use y bar. Basically, anytime you see an x, a lot of times you can plug in a y instead of x, and it's almost the same. So x bar is the symbol used to summarize the mean. And we calculate this with this formula. This just means, this symbol here, this thing that looks like an E or a sideways M, is the Greek letter sigma, and it just means add. Okay, so don't be intimidated by this thing, okay? You see symbols that you're not familiar with, it's easy to get intimidated, but don't be intimidated. Okay, this just means add. Do you remember what n was? N was the sample size, right? So n is the sample size, we already know this. And x here, without the bar, just means each data point. This means add. So this formula summarizes, I think, what we already know on how to calculate the mean, which is add up each data point and divide by how many you have, or divide by your sample size. We already knew this, right? I hope. Add up each data point and divide by your sample size. I'm sorry? This is sigma, and it doesn't... I'm sorry?
I thought you said it means equal. It means add.
The sigma means add.
It's a Greek word.
It's the Greek letter for S. Our letter S is derived from the Greek letter sigma. The Latin alphabet trace some of its origins to the Greek alphabet. That's all. If you don't like formulas, don't bother with them. Okay? You don't have to write all this stuff in your notes if you don't like it. I think you already know how to calculate the mean. And with the mean, so if we had the Baker family, Baker family's 4 kids. Their ages are, they have a 16-year-old, a 12-year-old, a 10-year-old, and a 6-year-old. What is the mean age of the Baker family kids? Well, we will allow the other students. Okay, so I should say this. Sometimes I will ask a question, and some of you will get it very quickly, and other students will not get it as quickly. So, if you get it very quickly, keep it to yourself, and then I will answer it together. Okay, so what is the mean age? Someone already shouted it out, but if you haven't calculated it yourself, go ahead and take this moment to do so. Okay, and so that would be, we would take each number, we would do 16 plus 12 plus 10 plus 6, and we divide by 4. So I get 44 divided by 4, a mean age of 11. Okay. All right, let's look at the Smith family. Let's say the Smith and Baker family are good friends because the first 3 kids are all the same age, okay? However, the Smith family did not plan to have a 4th child. But then they did, and so their 4th child is 1 year old. What is the mean age of the Smith family? Okay, so don't shout this out. What do we have here? Okay, so all right, so if we did this, we would do 39 divided by 4, and we would have 9.75. Okay, and so we can see that even though the first 3 kids are the same age for both the Smith and Baker family, in the Smith family, the youngest child is 1, and so that brings the overall average age down a couple years. Okay? So the mean is affected by numbers in the extreme. So extreme high or extreme low, the mean is affected by those numbers. Another interpretation for the mean is that the mean is the balancing point of our data. I believe I mentioned this last week, right? So if I were to draw a dot plot of the children in the Baker family, a dot at 16, 12, and 6. would serve as my balance point. Okay, this is the mean. Meanwhile, if I had a dot plot for the Smith family, in order for this to be balanced, the mean would be right there. So the mean is one way for us to summarize center. We can summarize center also with the median. The median is another way to summarize center. Yes, we have a question.
So 9.75. What was the mean for that one?
Yeah, the mean is 9.75. Or, I'm sorry, what? It's okay. If something doesn't quite make sense, don't hesitate to ask. All right. It's very bad to get confused in these first chapters because everything builds up on these. So yes, if anything I'm saying doesn't make sense, please interrupt me and I will try to clear up what's going on. Okay. So yes, please. Thank you for taking my advice here.
I'm a little confused. How can you be why doesn't it be closer to 10, but you're 9.75 years old?
The mean is just a summary number. It's not an actual person's age, okay? So we had two families, okay? And in the Smith family, the children's were aged 16, 12, 10, and 1. Okay? So in that family of 4 children, what is the average age? In that case, the mean age is 9.75. So,
Sorry, it's just so simple.
it's just a number to summarize the other 4 numbers. Okay, these are summary statistics. If you hear one thing, right? So you go to somebody's describing the Baker family, and you can say the Baker family has 4 kids, and the average age of those 4 kids is 11. And that gives you kind of an idea of what the Baker family might look like. Okay. You figure some kids are older than 11, some kids are less than 11. I don't know. This is what's going on. Okay. Of course, it doesn't tell us the whole picture. Somebody else says, the Smith family has 4 kids and the average age is 9.75. Gives us maybe another bit of insight. Again, when you're trying to summarize an entire family with just one number, the average age of their children, it's not going to give you the entire picture. You have no idea what this family is like, other than the average age of kids in this family is 9.75, and the average age of kids in this family is 11. So all we're doing is we're just taking the ages of the 4 kids and we're summarizing it with one single number.
I think it might be easier to explain it as like a class average grade, like to get the class average grades. A few people got this, and then you divided it to get the average of the whole class.
Okay, that's another way to calculate the mean. All right.
No, I'm thinking it might be simpler to
Okay.
understand stuff.
Okay. Yeah, that's the average class grade is this. All right. And I guess that's more relevant to you guys. But I guess I chose these examples because it's reasonable to have a family with 4 kids, whereas it's less common to have a class with only 4 students. And so averages are most useful, I don't know if most useful, are probably more useful when you have lots of numbers to summarize, but I didn't want to have to ask you guys to calculate the mean of 40 numbers or something. So that's the mean. Summarizes the data with just a single number. Over here, we've got the median, and we're also going to try to summarize our data with a single number called the median. The median tells us the halfway point, meaning once you find the median, that tells you that half of the data is larger than the median, half of the data is smaller than the median. Let's think of the Baker family again. What is the median age of the Baker family? So I have 4 children. I can draw a line right here at 11. And that means half of the children, 2 out of the 4 are older than 11. And I have 2 out of the 4 that are younger than 11. So the median age of the Baker family is 11. Is that okay conceptually? You don't have to worry about calculating it at this point. I'm just telling you, the median in the Baker family is 11. And do we see that half of the kids are older than 11 and half are younger? You can even look at your data. You have 16, 12, 10, and 6. 2 are older than 11, 2 are younger than 11. So with that, what is the median age of the Smith family? Okay, go ahead and tell me.
11.
Also 11. Okay, and the Smith family, the median age is also 11. 2 out of the 4 kids are older than 11. 2 out of the 4 kids are younger than 11 in the Smith family. So it's just a different number to kind of give us an idea of the other numbers. So the median is not affected by extreme values. Smith family is 11, the median age for the Baker family also 11. Yes?
What if it had marginal option? Like if it had 5, 10, 13, even 16. So it could be like 11 or 12.
Oh. Okay, yes. So I was just illustrating what the median is. I'm going to talk about calculating the median right now. But I just want to make sure that we understand this concept of median first. Okay. So if we have 300 people in our data, the median will be the point where, well, how many people have values larger than the median? I had 300 people in my data set.
150.
150 will have values larger than the median, and 150 will have values smaller than the median. And is it clear that the median is not affected by extreme values? So the Smith family, they have a 1-year-old, but it didn't matter if the youngest child was 1-year-old or 9 years old or 0 years old. It doesn't matter because it's just the point where half are larger, half are smaller. Okay, so to calculate the median, to find the median, the very first step, which is the most important step, but we often, well, I shouldn't say we, but students will often forget to do this step. But it's the most important one, is you must put the numbers in order from least to greatest. Do not do this step, your answer for finding the median will be completely wrong. You must put the numbers in order from least to greatest. Then, find the spot where half are bigger and half are smaller. Okay? Or in other words, find the number in the n plus 1 divided by 2th position. It is the number in this position that is the median. The median is not n plus 1 over 2. In the n plus 1 divided by 2 position. Okay, well that sounds weird. So what do I mean by that? Let's do an example. Okay, what is a numeric variable that I could possibly use for this example? So think of a numeric, just shout out a numeric variable you want to use. What's that? Shoe sizes. Okay, sure. Maybe I can get some volunteer data. So maybe we'll just ask the women's shoe sizes. And we'll just start off with student 1, student 2, student 3, and if you are willing to share your shoe size, just tell me. So
6.
Okay, shoe size is 6.
7.
7.
8.
8, okay.
9.
Alright, we're good?
6.
Okay, and another 6.
9.5.
I'm sorry?
9.5.
9.5.
8. 5.
And shoe size is 8.
9.
9.
7.5.
7.5. Let's get 2 more.
6. 5.
Okay, got a 6 and a what?
5.
And a 5. Great. So I have 10 students volunteered their shoe size, and this is the data. We want to find the median. What is my sample size here? Okay, so all of these students actually have names, but I just call them student 1, 2, 3, 4, 5, 6. So what is my sample size? N is equal to 10. Okay, what is my very first step? Put them in order from least to greatest. So I'm going to go 5. I'm going to just check off each number as I go. Then I think I have 3 students who have size 6. I have a 7, a 7.5, an 8, 2 8s, a 9, and a 9.5. Is that everybody? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 shoe sizes from least to greatest here. N is equal to 10. What is n plus 1 divided by 2? So the second step says find the number in the n plus 1 over 2's position. So what is n plus 1 divided by 2? Okay, n plus 1 divided by 2 is 11 divided by 2. I have 5.5. Is that step okay with everyone? No? Yes? Okay, good. So I did this, put the numbers in order from least to greatest, and now I'm going to find the number in this position. So I'm going to find the number in the 5.5 position. Okay, what is the number in the 5.5 position? 7. Alright. Number in the 5.5 position. Okay, so I'm just going to label these. First position, second position, third, fourth, fifth, sixth, seventh, 8, 9, and 10. Okay. So my 5th place number is 7, and my 6th place number is 7.5. So the 5.5 position number is a number between the 5th number and the 6th number. Okay? Yeah. So you guys, some of you can calculate that easily. That's great. But so the 5.5 position is between 7 and 7.5. Is that concept okay? So the number in the 5.5 position is, we're just going to say halfway between 7 and 7.5. And so if it is not easily clear to you, you would just take the mean of the 5th and 6th place number. So what is the average of 7 and 7.5? We would add these two together and then divide by 2. And then we get 7.25. So my median is 7.25. Yes.
You can also mark it down in each corner.
That is, when you have 10 numbers, it's very easy. You can just start to do this, okay? That is maybe how you learned in junior high or high school or something, okay? However, when you have a large set of numbers, 50 numbers, if they were on multiple rows of on a paper.
So what if there's more than
10 students, like say, let's say 10,000 students, how do you get median?
The exact same way, all right? So if there's 10,000 students, what is n plus 1 divided by 2?
But you cannot make them in order, like 10,000, like let's start 5, 6, 7, 8, again 6, 5.
You can, you certainly can put 10,000 students in order from least to greatest. Or do you disagree?
No, yeah, I can, but like it's impossible to write down like 10,000 numbers. So.
Oh, it would be very inconvenient to do it by hand. That is correct. Okay? If you had 10,000 numbers, it would be very inconvenient to do that by hand. And so you would probably enter them in a computer, and then you could just say computer sort these.
No, I didn't mean that actually, so okay. Okay, later on the next one.
Okay, no, go ahead and ask your question now, because I want to make sure we're okay with this.
Okay, so in this question there's 10 students and like everyone has each their own food size. So we put those food sizes in order, like greatest, smallest to the greatest.
Yes.
And when we get the median, we went to the 5th and 6th students.
Yes.
5th one and 6th student.
Yes.
So at the 10,000 students, and we're gonna go 5,000 students and 5,000 going on some. So
5,001 student.
yeah. Actually, never mind.
I'm sorry, I'm having troubles understanding what the difficulty is.
I'm gonna ask later.
All right. Are there any questions from anyone else? Okay. Well, let's try this out then. Okay. We'll take a moment here. All right. So maybe I could ask some of the men in the classroom to just shout out your shoe size. All right. Shh. Okay. So if any guys will volunteer their shoe size for me.
10.5.
10.5. 11. 11.
15.
15.
9.5.
9.5. 9. I'm sorry.
35.5.
I don't think we're in the American shoe size system. If we're all right, this is not a contest of who has the biggest feet. Okay. All right. Well, here, this is fine. Okay. We have six numbers that I will not question. Go ahead and find the median shoe size of these 6 numbers. In Europe, I have a size 43 shoe. So some of you I just see staring off into space. Maybe you've already completed the exercise, but if you haven't, I strongly encourage taking this time to do the exercise. This is an opportunity to just check your understanding, and then you can ask questions if you have trouble with the exercise. I'm going to write the answer. The median is equal to Alright, let's go over this. Maybe you're still working, but let's go over this. So the first thing to do is put these in order from least to greatest. So I have 9, 9.5, 10.5, 11, 11, 15. My n is equal to 6. N plus 1 divided by 2 is equal to 7 over 2, which is equal to 3.5. I label these 1, 2, 3, 4, 5, 6. I'm going to take the number between third and fourth place. So what is between... Okay, if I could just ask you guys to be quiet as I go over the answers here. 3.5, I'm sorry, between 10.5 and 11, so I add these two together, divide by 2, and they get 10.75. Is that okay? Yes.
Sorry, it says 1.5 plus 11 over 273. 3.5, so
10.5. So the third place number is 10.5. Fourth place number is 11. To get the median.
so
10.5 plus 11 divided by 2.
Yes. 10.5 plus 11 divided by 2. Might be doing something wrong in the calculator.
okay, so just so I understand, you find the position where it is, and then based on the numbers, it's between both of those numbers added divided by 2.
Yes, so according to the steps for finding median, stay quiet, you guys. I'm finding the number in the 3.5 position. So that means I'm going to find the number between the third place number and the fourth place number, okay? So what number is between the third place number and the fourth place number? Well, it's going to be the number between 10.5, which is my third place number, and 11, which is my fourth place number. So to get the number between this and this, I'm going to add these two together and divide by 2.
Okay.
And when I do that, I get 10.75.
And we're just calling it 3 and 4 because of this example right here. But in any line or in any equation, whatever numbers we were using, it is the next number that's over that you add to it and then divide by 2. Is that because look what you did here?
So
that's
so
5 and
it
6.
says I'm
Just
taking
in
the...
this particular example, it is number 3. 10.5 is number 3. 11 is number 4, correct?
Yes.
But in whatever line you're in, it's by the number that's on the other side. You understand what I'm saying?
It depends on if,
Like in women's shoe size, it's 5 and 6
Yes.
is where we find the median, between
Yes.
5 and 6.
Yes. Now
Yes,
how did
okay.
I know that it was going to be between 5 and 6? Because over here, n plus 1 divided by 2 gave me 5.5. And over here, n plus 1 divided by 2 gives me 3.5.
Yeah, I thought you were saying 3 and 4, and it was something that you carry over in every
So I have
example.
n plus 1 over 2 to find the position, and I get that number. This brings up a very good point. What do we do if we have an odd number of shoe sizes? Okay, so let's say a 7th student says he has a size 34 shoe, okay? And let's say this was an honest response, okay? How many numbers do I have now?
7.
I have 7 numbers, and where does 34 go? It goes over here at the very end. This would be the 7th place number. Okay? So what is my n? N is 7. What is n plus 1 over 2? N plus 1 over 2 is now equal to 4. What is my fourth place number? 11. So my fourth place number is 11, so my median is equal to 11. Yes?
For our quizzes, we don't have to show this word, we know how to do it differently, right? Like n plus 1 and all that stuff. If you know like a previous way that to find the median, we have
Okay,
to do
if-
it that way.
Right. If you can arrive at the median, so the median is something where you don't have to show a ton of work
Okay, I'm just
to get
saying, we have to
anything,
show
okay?
the
Yeah. All right, is that okay? Why don't we take a short break? 10 minutes?